So in this video, I'm going to give a brief introduction to custom image processing hardware, and I'm going to be doing some more videos in the future about the specific details of what modern image processing hardware is like. So for any custom hardware project, there's three questions that have to be answered in order to make sure you've got some decent idea for custom hardware. The first one is, do people actually care about the applications the hardware is going to run, right? So there's a lot of different, apps out there, but if you decide to make a custom chip to help improve, computer programs for generating interesting arrangements of knitting threads, that's probably not going to be a very good candidate for custom hardware because custom hardware is really expensive and the people interested in generating new knitting designs probably don't need it and probably don't have the money to pay for it. The next big question is, could the application performance demands be met by CPUs or GPUs or some existing architecture already? So for example, Microsoft Word is a super popular application. I mean, tons of people care about Microsoft Word and use it, but the vast majority of the time when people are typing on the keyboard in Microsoft Word, the app is running, plenty fast enough for their needs. Maybe it doesn't start up fast enough or they've got some minor complaints. But for the most part, the application performance demands are already met by CPUs and GPUs for word processors. And the last question is, how much could the new custom hardware that you design accelerate the target application? In other words, how much potential is there to accelerate the application beyond what CPUs and GPUs can already do? So, to go back to the second bullet for a second, suppose that there was actually someone, maybe they're a really fast typist, who's not satisfied with the performance of Microsoft Word on their CPU. You could imagine trying to design custom hardware for Microsoft Word. But the problem is that Microsoft Word, it includes, a bunch of data structures that I'm sure are filled with pointers that are used in text editing efficiently, and it includes workloads that require linearly scanning long documents to do find and replace, and it has facilities to load images and crop images and move clip art around and communicate with the operating system and the drivers in order to send things out to be printed. There's just so many different workloads and operations in Microsoft Word that there's probably not much benefit to creating custom hardware for it. And if you're not satisfied with your CPU's performance on Microsoft Word, you're probably just doomed and are going to have to wait for underlying transistor improvements in order to get higher performance because it doesn't have a very specialized workload. So let's just go through these questions for image processing, right? The first question is, do people actually care about image processing? And the answer is absolutely yeah, right? We're all visual creatures and, vision is probably our, strongest sense, or at least it's the one that we, are most attuned to in everyday life. And we put cameras all over the place, right? There's every mobile phone, tons of CCTVs and satellites. And on top of cameras, we've also got things like video streaming services and, screens that are displaying visual images all over the place. So there's a ton of interest, in image processing and, a ton of apps that people are really interested in art and science and pretty much every field. Okay, so could the performance demands of image processing be met by general purpose architectures? And, for some apps, yes, but for a lot, no. So if you think about just a simple case, suppose that you need to do some processing on a 1080p video stream. So it's 1920 by 1080 pixels. It's coming in real time at 30 frames per second, and your image processing pipeline needs to do about 100 operations on each pixel, which is actually a pretty small number. That already adds up to about 6 billion operations every second just to do this pipeline in real time. And if you think about it, a really fast CPU might have a clock frequency of 3.5 or 3.6 gigahertz at most. So you're already, even with this very simple kind of conservative pipeline, running up on the limits of CPU processing power. And the other one is that there's a lot of other difficult constraints, right? So apps that run on phones or on certain types of cameras need to run on very limited power. And of course, like I mentioned in this example, a lot of things like streaming services or real-time video processing have real-time performance constraints. So you can't just batch things and wait for them to finish. They've got to happen extremely fast. So there is a demand for performance that can't be provided by general-purpose architectures. And the last question is, could custom hardware actually do better than a CPU or a GPU? So, there's demand for higher performance, but is higher performance technically possible? And the answer here is yes, too. And the big reason for this is that, in image processing applications, unlike in things like Microsoft Word, you tend to have very regular, predictable memory access patterns, very simple control flow, and data gets reused a lot. And because of these three things, it's possible to take a piece of silicon and really specialize it to do that simple set of access patterns and specialize its caches, to really exploit the kinds of data reuse that you see, and also to cut down the size of the control path to free up some area and reduce the area cost of the different operations. So image processing is a really, really good candidate for custom hardware. It sort of checks all the boxes that you're looking at in a custom hardware project. And in the next couple of videos, we'll look at some examples of the kind of operations that image processing pipelines are made out of and how we can accelerate these in hardware.